Welcome to week 11, Introduction to Neural Networks. Neural networks are a subset of machine learning and artificial intelligence, and they're probably one of my favorite type of neural networks, or one of my favorite types of machine learning. Neural networks hold a lot of promise, and they're just interesting in the way they work. So I'm going through getting a computational PhD in neuroscience. So neuroscience, computational neuroscience, we really look at how biological neurons fire, which mirror how machine learning neurons fire, which we'll talk about here in a second. But over the next 3 weeks, we're going to go over neural networks. This week's going to be the basics of just plain vanilla neural networks. Next week will be, I believe next week's convolutional, and then the week after that is recurrent neural networks. There's a lot to learn on neural networks. Now, the issue is when I reviewed my notes from a couple years ago on neural networks, convolutional, CNN is the term for that, and RNN, they were all math-based. I mean, they were super heavy math-based. When I am at work, I don't normally use math. You know, I do use math for some other projects, but when I do neural networks and RNN and CNN, I don't generally do math. So I'm not trying to teach you the heavy math, the matrix math and the linear algebra, things like that. They're related to neural networks. I want to teach you the basics of neural networks. So when you're in a Tableau, or when you upload to Einstein, or when you get a report from somebody that is created on machine learning, you can kind of understand the basics of it. So if somebody asks you about it, you're prepared with, I guess, rudimentary understanding of the different types of neural networks. So today we're just going to go over the basics of neural networks, an explanation, the concept of neurons and their weights and biases, explain how data moves through network forward propagation, that's neural networks, and convolutional. Then backwards propagation is a recurrent neural network. We're not going to really go into this. I mean, we have a whole class on that. Activation functions with just how do you want your output, applications of neural networks and intelligence, okay? There are so many different ways that artificial intelligence has really changed business intelligence. And I mean, just we can finally parse out huge amounts of data. We can do things that weren't possible, we couldn't even dream of doing 5 years ago. You know, so let's go into a couple things here. So I have this first video, towards data science, the deep learning versus biological neurons, floating point numbers. This is it right here. Okay. Let's probably make it a little bit bigger here. Okay, biological neurons. Okay, so basically, this isn't a horrible description or a horrible picture, but that's the way you've seen them in every biology book since probably 5th grade. This is kind of what a neuron looks like. And what happens is that these axons, these terminals, connect to other basically neurons. So it's a chain. So this would be sometimes called an interneuron. So you have a soma, a cell body. You have dendrites, which are your inputs, and an axon. Now, a couple of the really key issues to remember here, that neurons in a biological model, okay, they have what they call an all or none action potential. So you could be getting a signal here, and it doesn't do anything. You get a signal here and it doesn't do anything. But then for some reason, you get a really big signal here, like somebody really hits your hand or something, and that signal is big enough that it travels basically down here to the axon hilly and basically creates an action potential and fires. Now, hopefully, it's big enough to connect to the next neuron to make it fire too and down the road. Okay. Now, a couple things too. There's something called temporal summation, time summation. So if you have multiple ones firing, even at a very small amount, sometimes they can sum up to enough to make a neuron fire. Okay. Also, sometimes there's a bunch of neurons that are firing together. This is called Hebb's law. We'll talk about it. So these are all kind of important concepts in biological neurons that have transferred over to artificial intelligence into machine neurons. Okay. Here's how basically neurons work. It's not really that important in this part here. Rate encoding is kind of what I was talking about. You know, if neuron receives only a small number of excitatory spikes, which would be inputs, it will produce very few spikes on its own. So small input, small output. Sometimes the output doesn't even ever happen. You have a lot of small inputs, it never actually produces a firing, it never fires a neuron. So remember too, but a lot of small ones can be summed together and create an action potential. So, okay, so deep learning neurons receive inputs or activations from other neurons. The activations are rate coded. So let's see what else. Activations are multiplied by synaptic weights. So that's how we do the learning. We go through a series of neurons, and some neurons are weighted more. Some are more important, some are less important. How do I recognize the face of somebody versus the face of somebody of a stranger? Well, the person that I recognize, those neurons that fire in my brain have a certain weight. And in theory, my brain can say, hey, if this neuron fires and this neuron fires and this one, but these three don't, that's that person. Times that by like 20 million. Yeah, the weighted neurons are summed together. Okay, that's an important process. And bias is a term added to the sum. So here's kind of how it works. So you can have a bunch of different inputs. You have a sum. A bias is, I don't want to say it's a cheat, it's a way to shift the value of that. Okay? And it's, again, without going into a lot of the math, it's sometimes hard. So remember, if my goal is to get to 10 or 1, let's say my goal is to get to 1, it makes a little bit more sense. And this one's firing at 0.1, 0.1, 0.1. This one's firing at 0.1, 0.1, 0.1. And this one's firing at 0.2, 0.2, 0.2. I'm at 0.4. Okay, even, you know, let's say I don't have a bias, let's not worry about it. I'm not going to activate the downstream neurons. Okay. Now, if this one is firing at 0.1, this one's firing at 0.1, this one's firing at 0.9, now I sum up to greater than 1. So, you know, my activation function will cap it at 1, let's say. And now I have an activation. I have an axon potential. Okay. So I think I just said to read down to, I don't know, somewhere. Inhibitory neurons also important too, but we don't. I think I said maybe just read down to here, advancing AI. So that's the basics, and you can kind of see the resemblance. So I have to scroll up and down. So these are your inputs. Okay. And this would be your activation down to another neuron. Your activation function would be right here. Your axon hilly. Your fire or don't fire. I also include a 2-minute neuroscience that talks a little bit about neurons. This is a little bit better video. It's 2 minutes. I mean, but basically gives you, because once you understand the biological functions and the biological basis of how machine learning was generated, then we can understand a lot more about how machine learning works. And I think I also include this one, which I will go into in a little bit. Yeah. You see this one kind of puts them right next to each other. So we have all of our weights, same picture as before. We have all of our inputs, inputs, okay? Subbody, and then outputs. Here's your outputs down here. They call activation, but these are your outputs. Okay? And that's why I really like that one. There's a couple other points in this article, but we'll talk about that in a bit. So, now Hebb's law is, Hebb was a neuroscientist from, I don't know, 1940s, 1950s, and he came up with a simple idea, Hebb's postulate, I believe is what it's called, or maybe it's 1907, I have it cited somewhere. It's that neurons that fire together, wire together. We say that one more time, because that is the basics of all neuroscience. That's the basics of all machine learning. Neurons, either in machine learning or in biology, that fire together, hey, they basically, hey, this one fires, this one fires, wire together, increase their weight, increase their synaptic connections. Practice makes perfect. Fire together, wire together. Practice makes perfect. Machine learning training, we can do test and train. We can make a prediction. It all comes down to the basic idea that, hey, we train something and we establish those pathways, and we add a bias and we add a wire and or neuronal pathway, it basically reinforces that pathway. Okay, so layers in a neural network: input, hidden, and output. Okay, so we're just keeping this super simple. You have inputs and outputs. Let's just start with that basics. Like I said, you can have 0.1, 0.1, and you're trying to get to an output. That one may not fire. 0.9, 0.9, your output may be capped at 1 because of an activation function. It's still, it fired. And data flows through a network. So now, on this week and next week, we're going to talk about forward propagation. That means that data can basically only flow in one direction, from input to output, from one neuron to the next neuron, from one neuron to the next neuron. So you have an input, you have a bunch of hidden layers, and then you have an output. In 3 weeks, I think it's when we talk about RNN. I don't know, maybe next week I talk about RNN. I redid all the slides for the next 3 weeks, so I'm going to do the videos one after the other. So RNN loops back, and it keeps track of sequential data, which is very, very important. While you may think it'd be great to have photographic memory, there's a lot of down effects to having a photographic memory. So neural networks and CNNs, data flows in a forward feed manner, from one neuron to the next, to another neuron to the next. While in a recurrent, hence the word recurrent, there is a recurrent connection that allows information from the previous step to influence the current step. This bias or gate, which is essential for processing sequential data. I guess I should put the word data in there. Okay, so here's kind of what it looks like in a bigger picture. One neuron, an output, input. Output, input. Output, input. They're all neurons. Here's one neuron. Here's the output that goes to input. This guy's output goes here, 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 here. This neurons, dendrites terminals, its terminals extend to all these other neurons. This machine learning node or neuron has connections to all these different neurons. So I'm just trying to, mix between biology and silica and computers. So deep learning is a subset of machine learning that deals with algorithms inspired by the structure and function of a human brain. Deep learning algorithms can work in an enormous amount of both structured and unstructured data. Deep learning's core concept lies in artificial neural network, which enables machine learning to make decisions. Now, it's not necessarily that it makes a decision. It makes weighted statistical judgments, just as we do. We are statistical machines. We're pattern recognizing machines. Even if you have no concept of math or even literature or word, or you can't write, go back to the oldest caveman. I mean, even without a written communication or anything else like this, our brain still were pattern recognition machines. I know that if I go here, and I can find berries one day, and then I go back and find berries the next day, I will eventually learn the fact that if I keep going to this spot, I can find food. Or if I keep going to this other spot and I keep getting poison ivy, I keep getting an itch, that's not good. It's a very bad itch, poison ivy, that I shouldn't go there without language. So our brains are statistical machines. Deep learning is a statistical model. We use those statistical models. We use that weight and bias, that pathway, to then, I guess, put new information in and try to figure out where we're at, or to look at information from past pathways and say, hey, it's an 80% chance of this. It's a berry. It might be a little different, but it looks like a berry. Let me try it. So now a couple of just random things I was thinking about when I wrote this. More layers allow the network to learn more complex features. And when we think about that, if we have this, we can't learn a whole lot. But let me get a video up of a lot of neurons. So while this is a gross oversimplification, if I know this is a 1, 2, or 3, I can only differentiate between the number 1, the number 2, and the number 3. I only have 3 input nodes. Here, I can say, hey, is that a 1? Is it a 2? Is it a 3? Is it a 4? Is it a 5? Is it a 6? Is it a 7? Is it an 8? Now, the way that true neural networks and computers and our brain works is we break down every basically pixel. But just for simple, for sake of argument, the more inputs and the more depth and the more layers we have, the more advanced or the more we can describe something, the more we can learn from something. I think depth, okay, so again, and as you can imagine, it adds more computation. So if I have to take, input and input and input, and I have 1, 2, 3, 4, 5, 6, 7, 8, I should have 9, right? It's something 9, 10, 12, 4 times 3, 12. I have 12 calculations, let's say I have to do, that result in, I don't know, 2 outputs, yes or no. Here, I guess I could calculate it out, but look at how much more calculation this is. The calculation just grows exponentially. I mean, once we start adding more layers and hidden layers, and we just keep adding these networks, and that is why GPUs have really changed the game of neural networks. This used to be very cumbersome and very hard to do on a computer. Now it's very practical to do on a GPU, more or less. So, okay, well, key breakthroughs, pre-trained network. So we're not going to go into a lot of transfer learning or maybe some pre-trained networks like ResNet and other things, but new activation set, batch normalization. I think it's ResNet, so let's not worry about that. Okay, so looking at the big picture, I guess I should scoot up so you can see a little bit more of me. Oh, there we go. My face just blurred again. Yeah, that's what I was doing before. Like my camera froze. So anyway, so big picture, you have neural networks. Just traditional neural networks. So that's sometimes they're called ANNs. I guess I should label that. You have convolutional neural networks. Okay, and those are used for image analysis, but more than that. We'll talk about that next week. Recurrent neural networks are more for sequential data or tabular data. There's a kind of an oddball network, but again, I love it. It's a general adversarial network. In a nutshell, I have a presentation I did on this a couple years ago, but in a nutshell, again, you have one machine learning model and another machine learning model, and you put them against each other. So GAN A might try to make a fake $20 bill, let's say. GAN B is your Secret Service, and they're trying to detect that fake $20 bill. So what happens is that your discriminator, your criminal that's making the fake $20 bill, gives it to the Secret Service agent. The Secret Service agent says, hey, that's not very good. It's pink. And then your generator basically says, hey, I need to make it green. And then gives it to the Secret Service agent and says, oh, this is better, but still has a picture of George Clooney on it, not George Washington. And fix it. And so it's this kind of battle where you have a generator and discriminator on your GANs, and they keep making images better and better and better by being adversarial to each other. So, and a lot of times you'll use a GAN like before CNN or after. There's a bunch of different things you can do with GANs. But GANs are very, very, very important. So I think that Synthetica that I used to make all that fake patient data, I think that was trained on a GAN. So basically what that can do, if you think about it, is that if we have a bunch of patient data, just tabular data, not even images, just tabular data, and I want to make some fake data, I can have a discriminator or Secret Service agent say, hey, I made this name. Does it look like a real name? And the discriminator can be like, no, it doesn't. It's a horrible name. Let's just threw a bunch of letters in there. Try again. And we can train a machine learning model to basically take synthetic information and make it almost as real as possible. I mean, I looked on, like I said, if you go to the SQL server, there's a table called Synthetica. I think it either has 10,000 or maybe 1 million fake patient names. And I looked at some of the addresses. I mean, it like found real medical addresses. It found real zip codes in Nevada. I mean, it did a really good job at generating synthetic data. So GANs can be quite, that's where all the deepfakes come from, is starting from GANs. So they're quite amazing. Now, transformers. Okay, so transformers are a newer type of model. I guess so are GANs. Ian Goodman wrote this, I think it's Goodman, 2016, 2017, something. And transformers are kind of a way to do focus. Transformers is a deep learning model that adopts a mechanism of self-attention. A differentiating way, okay, that's way too complex. So let's think about this for a second. So there's a cocktail party problem in machine learning. Let's see, cocktail. Let me see if I can explain that. Well, I can't find any really good descriptions of it. So a cocktail problem is me and you as humans can go into a room, a restaurant, and have multiple conversations around us, but we can only, or we can focus on the person in front of us. Computers have a really, really difficult time doing this, okay? That attention is very difficult for machines. Recurrent neural networks and LTL, long short-term memory machines can do a little bit better, but still. So you need to focus on your words in front of you, of your friend's word at the cocktail party. You know, hey, he's talking, I need to focus on him. So this is kind of where transformers have made huge breakthroughs. That they've made this big leap in learning. So with transformers, they are able to understand who's basically has the attention, who's talking. Okay, they have an attention feature. And not only that, then they can listen to other conversations if needed. They can learn from a lot of different inputs. I know that's kind of hard to explain, but you know, when you have a lot of data, so let's talk about the stock market, for example. The stock market is a great example. If I have stock market data, I have a lot of data, years and years. Let's say I look at GM, or what's that beer, Guinness. Maybe, I don't know if it's publicly traded, or that Japanese beer that's been around for a couple hundred years. If I look at all the open and close of that stock for 100 years, how do I know if that stock's going to go up or down or not? And this is one of the big problems with a lot of people trying to do stock market analysis, is they look at the data, but the data doesn't say, hey, maybe we have a new CEO. Maybe we have a new manufacturing process. Maybe we have a GMO yeast that can increase yield. Okay? So we look at this huge, long amount of data. And we have a hard time saying, hey, so from 1900 to 1950s, we showed a 12% increase. From 1950s to 2000s, we showed an 18% increase. Well, if I just average those two and use some fancy math, I can say I'm getting between 12 and 18% increase in the next 20 or 50 years. The problem is it doesn't really work that way. We have to have attention to maybe each year to small changes. Okay? And this is where transformers have really changed machine learning. So transformers are the part of what's behind ChatGPT and the large language models. So I just want you to have a general idea. So ANNs, deep neural networks, convolutional neural networks for images or other things besides images, RNNs for time-based or sequential-based data. And when we look at the stock market, we just can't put all the prices from high to low in a big Excel spreadsheet and average them. What happened last year or last month versus last day, order matters, okay? Generative GANs are two machine learning models against each other, okay? And transformers, where they have attention or focus. Okay, activation functions. Sorry, this is pretty intense, but activation functions are important too. And these are all really big picture ideas until you get in there and really dive in. Okay, so the way I think about activation functions is like grades. Okay, so you all have a bunch of inputs. Everyone in this class has a bunch of inputs. All the discussions, all the assignments, all the extra credit. You all have a bunch of inputs. Now, if my activation function is a pass-fail, it's either you're going to pass or you're going to fail. At the end of the semester, what I submit to the registrar or what I submit to the university is the activation function. The output is a pass or fail. Nothing else matters. It's just a pass or fail. Okay? And so that would be like a binary classification, a sigmoid function. Okay, yeah, sigmoid. I do. What do you know? I guess that kind of makes sense. I guess I could do that. So a sigmoid function actually gives you between 0 and 1. Okay, but again, it's not super common, but you get the idea. So hey, you have an 80% in this class. It's pass-fail class, you pass. You have a 20% class, you fail. So that's kind of how you think of an activation function. Activation functions you often pick for the simplest ideas. You put them at the end of your neuron to do an action. Okay. Now there are times in different models where you can put activation functions in the middle between your hidden layers to kind of clean up dead data. But we're not going to necessarily go into that. Now, what about if you have an A, B, C, D, F, like a normal American grading system? Okay. So if you have 112%, what do you get? An A. Because we have an activation function that kind of compresses that data down to 90 to 100%. If you have a 23% in this class, what do you get? An F. So our activation function is basically saying, hey, go to an A, go to a B. It kind of truncates all this data down. Okay. So what else? Multi, softmax, ReLU. That's the name of my Wi-Fi. Hey guys, there's ReLU right there. What else? There's a couple others, but let me think what I want to go into. Yeah, the basic activation functions that you can't pass. So an activation function, we'll go back here. Right here. Well, you know what? Activation function. Okay, so we look at this again. You got 100% on discussion 1, 110% on discussion 2, 108% on discussion 3. You have all, so the sum of all your grades or your scores 108%. Now I can't submit 108% to the register. So I put an activation function in it, and boom, you get an A. Okay, so you have a B on this discussion, you have a B on your midterm, you have a C on this. The sum of all your grades comes up to a C minus, 72.8%. The activation function says it's a C. So that's kind of how you have to imagine activation function. It kind of gates everything to either yes or no in terms of binary. How much, you know, I guess that makes good sense. So yeah, you have to use the right activation function for a specific task. And so if we're using binary classification, we use sigmoid often. There's other ones. We want multi-class, we use softmax. Now why is that? Because if we are trying to catch a baseball, we need to have dexterity, movement. We need to have like fine motor skills. Okay. If we're trying to take a hammer and split wood, we use a different activation function. We use different muscles. We're not using as much fine motor control. We just want every neuron to fire so we can split that wood in half. You know, versus very small tactile movements. Okay. So those are different activations in our body. And the same can be said in machine learning. If you guys have questions, let me know. Activation functions are just kind of one of those unique things, and they're super important. So, applications of neural networks in business intelligence. Okay, so now why is neural networks in general and business intelligence so important? We covered, hopefully there's no math in what I covered, but so why am I so passionate about this? Because in my opinion, neural networks, any type of them, will have and will continue to change business. You know, I mean, I picked ChatGPT. Do I need to say more? This class, hopefully you guys have been exposed a little bit to ChatGPT, but in the business world, it is making huge advances, okay? Between chatbots that actually work, between writing letters to patients in different languages that helps understand their medical condition. I mean, ChatGPT just by itself has fundamentally changed business, and that's just one example of a neural network. Self-driving vehicles. I mean, maybe 10 years, 2 years, 18 years. Soon, self-driving vehicles, self-driving at least trucks, let's say semi-trucks, will be safer than human-driven trucks. Okay, so there's a lot that has huge impacts on business. Being able to target subgroups, being able to understand disease prediction, all these things are key and very vital in business intelligence. Okay, and also too, we collect so much data. I mean, it's just, I wish you guys could understand how much data is out there. I mean, you just look at your cell phone, and your cell phone is connected right now probably to 5 or 10 different cell towers. Each one of those cell towers is giving a signal, and that's being recorded somewhere. Let's see if I can find out. Hold on. Yeah, I couldn't find a quick video, but I mean, if you think, let's say we're connected right now between 5 and 10 cell towers, and it monitors that every millisecond or every tenth of a second. I mean, that's 10 cell towers making a log for, 24 hours a day of every phone in Vegas. Just think about how much data that is. Your watch, same thing. Your car, your car collection, how many miles, speed, brake pressure, air pressure, barometric pressure, throttle input. Just hundreds of variables in your car collected every second. So there's just a ton of data out there, and it's almost impossible sometimes to analyze without a lot of neural networks. So also another thing too, one of the things that's really changed is that neural networks or deep learning or machine learning have allowed non-technical people to at least start entering into the world of data analytics. And it's good. If you have a data set that's so big and so massive, you don't know how to handle it. There's Ask Data, which I believe is a Tableau product. You just kind of upload the data and you can literally ask it in natural language. Hey, how many sales do I have this week? Or what's my year-over-year return? And so Ask Data, for example, uses machine learning. And there's a bunch of other products like this too. I think Spot's one of them. So there's a couple of them. Basically, you just upload a tabular data and let machine learning kind of process it, and then you can ask it in natural language about that data. And so you'll start seeing those a lot more common. Again, we're going to go over this in next week and the week after that. But a convolutional network and big picture ideas is you're just kind of taking a convolutional function of a part of a picture and you go chunk, 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 and you take all these chunks and you kind of, summarization is not the word, but you summarize it, you define features of it. Hey, if I'm looking at this 2 column, there might be a line right here and there might be a line right here. So you start pulling patterns out. Okay, you build on enough of these features, you can start recognizing patterns, and once you start recognizing patterns, then you can say, hey, this is a car, this is a truck, this is a cat versus a dog. That's a very common, I think, CNN that you can find on the internet. Hey, is it a dog or cat? Now, recurrent neural networks, so if you notice right here, okay, you have this kind of loop back feature. So you basically have an input, here's blue, you go to this neuron, and then this neuron can keep information from the past state. It can add bias, it can basically forget it, or it can move it forward. And this is important for sequential learning. And what do I mean by sequential learning? So if I was to give you a dictionary and just scramble all the words together, how useful would that be? Not useful at all. If I took this class and just randomly put every slideshow or every PowerPoint slide in a random order, it would be completely useless. So humans, and for the most part machines, sequential order can be very, very important. Now for other things, not so much so. So that's why sometimes we use convolutional neural networks, we use recurrent neural networks. Those are big picture differences. So kind of where AI is now, I wasn't sure how to kind of wrap this lecture up, so I just wanted to talk not necessarily about the state of the union of AI and business intelligence, but just kind of about the state of the union, I guess. Let me see if I can grab some of these links. Okay, so big picture, small picture. So big picture, Python can pretty much do almost any type of machine learning. And for the most part, most modern programming languages can. Python tends to be a little better, a little easier, but I just saw something yesterday on C+ where they're using really heavy machine learning. So don't think it's just Python. It's MATLAB, or it can be Excel, or it can be Python, or it can be C, it can be VBS, it can be any of these languages. At the end of the day, Python is a major player. The way it kind of works in our world, kind of 2 different ways, is that we have a team that will kind of either create a machine learning model and we'll receive the output and then we'll visualize it. That's very common. Or I'll create a machine learning model and then pass it off to somebody else to use. We've done that. So that's done in Python, and a lot of the heavy lifting is done in Python. Then we move it up. Not really dimensional reduction, but we move it up to somebody else to visualize, or we move it to another product to visualize. Now, Power BI and Tableau, they can do some machine learning built in. But they're also, and I'll talk about this in the next slide, they're also a lot more common to have cloud-based solutions. And there's a lot of reasons for that I'll talk about. So, hey, tutorial, how to build a machine learning model in Power BI. I think this is just a real low-laying model, so it's not like a CNN. But I've done RNN in Tableau using Einstein, I think. So there are ways to do more deep learning in both Power BI and in Tableau. Now, it's not super common. Why is it not super common? Because, again, it requires a great deal of compute. And a lot of computers don't have a GPU to do that. So on the next slide, I'm going to talk about cloud computing and how they kind of solve this and the pros and cons of that. So it can be done on your desktop. And it can be done in Python. Now, the big picture right here is cloud-based. So if I was to pull up the Pirate Bay right now and look, there's probably Power BI, there's probably Tableau, there's Excel, there's a million different products out there, okay? You can download them illegally and you can use them illegally, and a lot of businesses do. And again, it's illegal. So so if I am a business, how do I prevent that? Well, one way is I can make everything cloud-based. So now let's talk about some of the benefits of that. So if I have my data set in Tableau and I need to process it and I need millions and billions of calculations, okay? Matter of fact, I did this in a Tableau demo probably last year. If you probably want to Google it, there's a Tableau demo of where to place, we were just talking about cell phone, where to place the best cell phone towers. So it's a geospatial analysis using deep learning. And we had millions and millions and millions of rows. Well, we were using laptops in this demo. It was a Tableau paid for demo. And we had to upload our data to a cloud processing, to a Tableau Salesforce processing unit and pull it back down. Now, Tableau loves this. Why? Because they can bill for those hours. So if I upload my data, they can bill for that. And when they process, they can bill for that. And then I want to make changes, they can bill for that. So cloud-based is very, very, very popular for a lot of vendors, meaning Power BI, Alteryx, Tableau. I mean, any MATLAB, anything. They love cloud-based solutions. Why? Because also you can't steal it. I mean, they're cloud-based solutions. Okay. And I mean, now you can be on a Chromebook and be doing super advanced machine learning because you're using a cloud-based solution. I mean, think of Google Colab. Google Colab, you can attach, I don't know, a $20,000 GPU with the click of a button. So Tableau, Power BI, and all these vendors really do try to push you to cloud-based solutions for deep learning. Now, the problem is, what if you have sensitive data? How much do you trust that sensitive information to that vendor? Is that vendor going to use your information to make money too? And you don't think they do? They might. Look at Amazon's lawsuits about how they've used third-party, or I guess vendors or customers' data to make money. So Amazon has been, I guess, charged with in the past of saying, hey, this product makes a lot of money, so we should make this product ourselves, the Amazon Basic line. And they're saying that a lot of what Amazon did was illegal. So you can Google that and find out if you want. So again, cloud-based solutions are here and they're going to grow. Just keep in mind kind of the pros and cons of them and why businesses like them. For a business that's going to a cloud-based solution, so for example, if I have Tableau and let's say I am a company, I'm MGM Studios, or I'm MGM Casinos, sorry. I'm MGM Casinos, and I pay Salesforce $500 a year for a person to use Tableau. That's a fixed expense. I know every year I have to pay Salesforce $500 so that my analysts can use Tableau. $500, use Tableau. $500, use Tableau. Now, when you move to a cloud-based solution, here's $0. Well, that's weird. I didn't give you any money. But as soon as you start processing data, is it $10? Is it $10,000? Did the analyst forget to turn off the processing? Did he overprocess the data? I mean, it's impossible to predict the correct amount of billing as an MGM casino that my analysts will use when uploading to a cloud. There are some constraints and some things you can do about that, but That makes it really hard for MGM to try to budget next year's machine learning spend because it's all cloud-based. So that is one of the drawbacks of cloud-based. And again, privacy and security. While it may seem like it's really easy and it's super secure, getting the data up there and allowing GPU to process it, allowing machines to process it, putting it in a database, pulling it down, there's a lot of errors, a lot of places for security faults. So just keep that in mind. I should have made this its own slide. Adoption is growing. I mean, machine learning is going to be everywhere in business intelligence. It's going to be less math and more easy. Okay, so just keep that in mind. Now, another thing too that you'll see that machine learning is not going to be take my job away. It might, and I could be wrong. A lot of machine learning and business intelligence right now is augmenting human intelligence. And what do I mean by that? So my wife is working on PowerPoint right now, and there's a button on the right side that says designer. She can click it and it will automatically lay out her slides for her. ChatGPT. If I just ask ChatGPT to do something, I don't know. Let's see if we can do it. It might maybe work. ChatGPT. Let's see, ChatGPT. Just new chat. Do something. So it doesn't really do anything. You have to it's designed to augment us as a human. So the automatic slide layout in PowerPoint, the chat GPT, the new searches, it's not really designed to replace us. It's designed to augment us. Okay, it's designed to say, hey, as an analyst, I have Tableau and I can make a PowerPoint, but now that I have better data, what more can I do with my report? Focus on natural language. That's something that's relatively new in the last 2 or 3 years, but in terms of business intelligence and machine learning, not only do we have visual, pictures, we can now have stories to tell. We can take that ask data, Tableau, ask data. I don't ever use it because we're not authorized to use it. But basically, you can just say, hey, like type a question here, and it will give you an answer. And this is becoming more and more important too. Okay, so let's see what else we have. There's also AI models for model development. So I talked about different activation functions, softmax, ReLU, TAN, there's a bunch of them. I talked about CNN, RNN, and there's 100 different types of neural network specifications. It's really complex. It's really, really complex. And you can specialize just in GANs and spend your whole life just doing GANs. You can specialize in doing recurrent neural networks. So as a non-technical person, how do I expect you to use machine learning? It's a great question. And then on that, there's hundreds of parameters to tune, batch size, epic. I mean, just a ton of stuff. How do you do it? Well, in the last couple of years, auto ML has becoming more and more popular. And this is particularly you see on the cloud too. Hey, I upload a data set, and I want to derive X amount of information out of it. Well, auto ML will select the best model, kind of tune your parameters, and give you the end results. It is pretty amazing. It works pretty well, actually, for within reason. I mean, if you have tabular data, it works really well. So that is something that we see coming in business intelligence rapidly. Where you can have a basic auto ML model, maybe for your desktop, that kind of does a rudimentary, your basic stats and your basic information. But if you really want to get more accurate, let's upload it to a cloud. Data preparation and automation. We've all been cleaning data this whole year. We know how much it sucks. Machine learning can kind of do that now more automatic. Again, there's a lot of challenges that remain. The midterm talked about challenges. I think one of your discussion posts, you're going to have to enumerate a challenge or a risk and kind of how you plan to mitigate that risk. So those are okay. So where we're at so far. So we have your teach back assignment. I call it something else in the actual web campus. It is officially called what is it called? Data-driven solutions presentation. Okay. So that is for the month of November. This is your project. This is what you have to do. The teams are smaller, teams of two, just two people. They've been randomly assigned. You find them here under people. Okay. So the general idea of this is that, hey, I want you to teach me something. There's kind of a couple different ways you can attack this solution or to this problem. You can pretend that you're a more senior business intelligence person and you want to teach a junior data scientist, junior business intelligence person something. And, one way to think about that is, say, you're almost done with this class. What would you teach next year's students? That's one way to think about it. Another way that I originally came up with the idea, even though it's kind of not really written in there, is a big part of data science and business intelligence is buying tools. Trying to convince people that, hey, yes, spending $10,000 a year on this tool is worth it. Spending $10,000 a year on the cloud-based solutions is worth it. And that is where this project originally came up from. Hey, I want to do X, Y, and Z. Here's a product. Here's a demo. Please let me buy this product. So work with your groups, work with your team, or your two people teams on this teach back assignment. I'm pretty liberal as far as what you want to do. You can do a bunch of little TikTok videos. There's a guy I follow that does PowerPoint videos. Hey, there's a problem with PowerPoint. Here's how to fix it. And he pushes out like 10 videos. So as long as you get like 8 to 10 TikTok videos, that works. If you want to do one big video in like what I do, what I teach, that works fine. Like one of my demos, that's fine. The two deliverables, the two MVPs for this is a video on YouTube or someplace that I can access it, and an outline. Now the outline you don't have to release to anybody but me. You just put it part of your assignment, but your outline just shows that, hey, here's a problem, here's the product, here's the solution. Again, it's in the web campus. The discussion topics. So here's the rest of the discussion topics for the rest of the semester. We have this neural network machine learning challenge. I don't think it's due for another week or two. Part one, I want you to kind of think about a risk or list a risk. Now, you can just watch the midterm, and the midterm will basically enumerate multiple risks of machine learning. And then once you list a risk, that's hard to say, I want you to tell me how you're going to prevent that risk. And you don't have to be like, I'm going to attack the computers and kill Skynet. No, that's not what I'm asking. So here is an example. I was part of a project recently, and I'm trying to think if the project's closed out so I can talk about it, where we were going to have patients wear kind of like a watch, a device, we'll say, that track their breathing. Okay, well, that's good. If they have breathing that slows down and have a hard time breathing, we can have a doctor or nurse call them to take a nebulizer, I guess a nebulizer. So far, so great. So far, everything's good. I'm happy. Well, that device also tracks when the patient wears it. Okay, that's not necessarily a problem, but it tracks the location of where they're wearing it at. So that is a problem. I don't want my patients to be tracked with their location data without them really knowing that, hey, this device is designed to track your breathing. It's designed to help you medically to make sure you breathe. And it's also going to track your location. So if you go out and party or you go out to a friend's house to spend the night, this device will know that. This device will know that. And so what my mitigating strategy was is I won't sign off on that device. I will not give approval to that device until that data is either anonymized, removed, or that data does not get passed on to a third party. So again, it's not like I'm creating some robot that's going to go out and destroy that company. No. The problem is, hey, this device will track the patient's whereabouts with or without their knowledge. I don't want it in some little terms of service that nobody's ever going to read. So what am I going to do to prevent that? I'm going to speak up and use my voice and say, hey, I will not sign off on this until this data is anonymized, this data is de-identified, this data doesn't get to a third party. Okay? So that's kind of what I'm looking for. And there's tons of them. In the midterm, I talk about how Nissan, not the electric car, just Nissan generally knows if the driver is a male or female of the car. And they use that to sell that information when you go to a dealership to sell to marketing companies. So what does that mean? Maybe I don't buy a Nissan. So that's the discussion that due, I think, is this week. December 3rd. So there's no more discussion for the rest of the month. We're going to go in the RNN, CNN. There's a discussion due on December 3rd. That discussion is simply your teach back video, your data-driven proposal. This. You put the email in the assignment, or the link to the video in the assignment. You put your outline here in this actual assignment. Then you also post it in a discussion. One of the team members will post the video in the discussion. The other team member, both by Thursday, will post in the discussion saying, hey, here's why we did it, or an outline, or a PowerPoint, or any other information you want. Just as long as both people post, you're good. You're gravy. That's the word of the day, I guess, gravy. Then you make a follow-up on another team's teach back. So that's due by Sunday. Then, right before finals week, there's one last discussion, and it's just data decision management. So after, or in December, I want to move away from the heavy computational machine learning, heavy, I don't want to say math, but the hard science, and move to the soft science. Okay, we talked a little bit about cognitive bias. We talked a little bit about lean. So that's where I'm going to kind of go back and try to help drive data decision making, decision support services. I'll come up with a couple of demos this week, so that's where we're at. If you guys have questions, please feel free to let me know. Again, try not to get down too deep in the nitty-gritty and the AI stuff. Learn the big picture stuff. CNN, ANN, RNN. Learn that, hey, there's a bunch of different activation functions, and I may not know what the activation function does, but I know it kind of compresses the output to either 1 or 0, or it goes from -1 to +1. It gives me a standardized format that I can do something with. Know how some neural networks feed backwards, backpropagation. Know that some of them go forward. Just big picture stuff. That's the goal of this class. Big picture stuff with machine learning. I'll get the demo up in later today or tomorrow. Thank you.